Alright, so this is problem 3 from test 2, and we're given that there is a shell of charge at the origin with a positive charge of 2 times 10 to the negative 9 coulombs. And what they want us to find here in this problem is the potential difference relative to infinity. So we know the formula for potential difference is equal to the negative integral of the electric field dotted with the path that it takes. But what we don't know is our limits of integration. So we know that we're starting from infinity and we are going to our x point, which in this case is 0.04, but we're not going to put that in just yet. So then the electric field for a sphere of charge we know to be similar to a point charge, and we can write that out here, the point charge formula. And then we'll just take out the constants here to make it a little easier. Okay, now we're going to take the antiderivative. And we see here that this is what we get. And we're taking that from infinity to x. Next thing we're going to do is plug in our limits of integration. And we will get negative 1 over x minus negative 1 over infinity. And we know this term goes to 0 because infinity is in the denominator. And so let's see what we get here. We can cross out these negatives. And we get that the potential difference is equal to q over 4 pi epsilon naught over x. And then we know our q to be 2e to the negative 9. We know the constants to be 9e to the 9th. And we know our x in this situation is 0.04 because that is what we were asked in the problem statement. And all of that turns out to equal 450 volts. This is important that you do the right units because that's what I got wrong. Potential difference is in volts. And also note that because we are going from far away from the charge to a closer to a positive charge, that means that the potential difference is going to be positive, and I did that wrong on the test as well. So that is problem 3A from test 2, and I hope you enjoyed it.